Number 8 asks, a boat moves through the water with two forces acting on it. One is a 1500 Newton force, forward push by the water on the propeller, and the other is a 1200 Newton resistive force due to the water around the bow. It wants to know what is the acceleration of the 800 kilogram boat in meters per second squared, and it wants to know if it started from rest, how far will the boat move in 5 seconds? And last thing it asks is, what will its velocity be at the end of that time? So here's what we do know. We know that we have force 1 is 1500 and force 2 is negative 1200, and these are newtons. We also know that the mass is 800 kilograms, and so it actually breaks the a multi-step thing down for us, so we're not trying to cram multiple equations into one equation, because we're going to be solving each equation as we go. So what do I mean by that? So it asks for the acceleration. When we know force equals mass times acceleration, so force over mass equals acceleration. And then in part B, it says, if it starts at rest, how far will it move in 5 seconds? Well, the distance, the change in distance, the change in x, equals the initial velocity times time, plus, and I'm going to come down here, plus 1/2 of the acceleration times time squared. So instead of taking this and inserting it right here, which is what we would do if it didn't break all of these down into separate parts for us, we're going to first solve for acceleration, then we'll plug that number in to this formula. So let's go ahead and start. 1500 minus 1200. So this is my resultant. My resultant force is 300 newtons. So I got 300 over 800 is 0.375 meters per second squared. So 0.375 meters per second squared, that's the acceleration on this 800 kilogram boat. And so the next thing it asks us, remember the change of x equals the initial velocity times time plus 1/2 of the acceleration times time squared. And now if you're wondering how did I get this formula, I can derive it. I can show you how to derive it. If you need that, post in the comments, but I think it's probably one in the textbook too, so you can memorize it, or you can learn the two simpler equations that it comes from. So anyway, with that said, we can take our 0.375 and put it in here. It's asking us how far will it go in 5 seconds, so replace your t with 5. So this would be 5 squared, so this term will be 25. And we know that the initial velocity, it started from rest, so the initial velocity is 0. 0 times anything is 0. We can get rid of that. So 1/2, so the change in x equals 1/2 of 0.375 times 25. So you're going to get that your change of x, the distance traveled, is going to be equal to 4.6875 meters. In 5 seconds you went 4.5 meters approximately. And then the last thing it asks is, what will its velocity be at the end of this time? So we know that the definition of acceleration is the change in velocity over time. And so we know that we have a 5-second time interval. We know that we have an acceleration of 0.375 meters per second squared. So we need to solve this. So final velocity is the initial velocity plus acceleration times time. And so the initial velocity is 0, so we know our final velocity equals 0.375 times 5, which is approximately, the final velocity will be 1.875 meters per second.